So today I'm going to be talking about the offline web, and when I'm trying to think about design problems, I need to start with some sort of conceptual model. So this is my conceptual model for the offline web. Basically, the persistence of experience for distant sources of context. Now, like a lot of people, I think very three-dimensionally when I'm thinking about problems. So when I'm on the web, I consider content to have like distance from me. I feel like a little facade, like a surface that's in front of me, which is the devices I'm using, either a laptop or a mobile phone. And then there's these bits of content that live at distance away from me. I don't know where, but they are at distance from me. And the offline experience is the persistence of that experience close to me. And I think the word persistence is really interesting and really sums it up to me when trying to construct the offline. Because if you look at the definition of persistence, it's the continuing in a course of action in spite of the difficulty or opposition. And to hold something offline definitely needs some sort of force or action, continual force or action to actually keep it there. It degrades otherwise. You know, you have to keep updating the information. You have to sync it. You need to make sure it's up to date all the time. There's like a persistent effort that's needed. So that word is quite important. So a lot of what I'm going to be talking about is me using this type of model, and I particularly chose these words because it gives me a very wide scope as well. I didn't want to narrow down how I perceive the offline web to some sort of like single page application or some other sort of mental model. So this really helps me to keep referring back to it. End of the philosophy bit. Okay, so from now on we'll just move into the next bit, which is to look at some of the design patterns and some of the recent design patterns. Although I was thinking about this about 14 months ago when I actually built the library. So this is the Washington Post's new progressive web app, hence the PWA directory. It's only been out a few weeks. If you use a mobile device and you go to this URL, you'll find that they've built a completely separate UI away from their main site. It's not the sort of like desktop site. It's actually completely sort of a greenfield built site that sits all its own in this little directory. We'll come on to why I think that's not a particularly good idea. But it is actually really fast, and if you go on there, it persists. It's offline. They've got like sub 100 millisecond page loads for some of their articles, which is just unbelievable. On the downside, if you hit it with a non-mobile browser, you get this page on this side, which is basically like the old sort of splash screens you used to get, saying this site doesn't work on IA6 or this site doesn't work with this technology. You know, it's a bit of a sort of slight step backwards. And in actual fact, Andrew Bates, and if you don't know this name, this was the person who led up the Financial Times FT Lab. So they've got like a lot of background in this area. They've been building sort of offline experiences using the slightly older technology, the AppCatch technology, for quite a long time. You know, and have done a lot of work in this area. Wrote quite a passionate piece. And I have to be quite careful here because both the Washington Post and the FT are both clients of Asyncjs, so my words will be chosen carefully. He wasn't overly happy about the Washington Post's piece, and he wrote this article. It's well worth you having a read of it. I've got the URLs at the end. You can use the URLs that I've listed for you. And towards the end of the piece, after he talked about why he wasn't happy, he then did sort of a more positive thing and listed a whole series of bullet points about what the community in general could do to improve the position. And one of these bullet points was this one here, where he said basically we should focus on adding these new sort of offline features to mature sites. And this was definitely my thinking a while back, and I sort of knew this problem was going to come and raise its ugly head at some point, and now is the time. Now is the time we're having this debate. So for me, when I was thinking about offline experiences, I moved back to some of the websites that I helped design, well, 5 years ago. So I did the first 2 iterations of the design work on the Guardian jobs site in conjunction with the product team at Guardian, and I think it was Flow Interactive as well, who did a lot of the user research for us. And this to me represents, and the reason why I'm showing you this, and I'm going to show you a few examples of this site, it represents one of these mature sites to me. It's got some of the features, and you know, it's been around for a while. You know, it's got millions of users. It's, you know, it's a heavily used site, and it's been through multiple iterations to get to the point that it's at the moment. Unlike most modern sites, it's got a responsive layout. And typical of most of the sort of responsive layouts of today, as the screen real estate changes, there's some reduction in the features and also some paring back in some of the material that's on there, but just generally it just reorganizes itself to best show the features that are there without actually degrading the user experience if possible. Pretty classic. I think we're all very familiar with that type of thing. So there I was thinking about this and thinking, okay, so if I take my mature site, my Guardian site, what would it look like if I built a offline experience? And particularly, what would it look like if I built a progressive offline experience? One that was iterative and started with like relatively small thing and built on the site as it was, not like the Washington Post did, like build a brand new site and stick it in another domain. And before I show you this little mock-up, I've just got to say, caveat, big caveat, this is not what Manchix is doing for the Guardian or what the Guardian asked for. This is purely just me mocking it up to see what I would think about. And if I was doing that type of thing, I'd probably come up with a design that's a bit like this. Now, the Guardian jobs has about, at any one time, between 12 and 15,000 jobs on it. Those jobs rotate every 28 days. That means a job changes less than every 3 minutes on it. So it's actually a very high data traffic in site. I don't think we could dump all of that data from the main site into a client because it's just not very practical. The amount of updates we'd have to send to the phone would be really substantial. But there are lots of things on that site that are really useful to the user that we could possibly translate over. So I've just picked a few of them out, which I think would be quite useful. One of the things that users do is to shortlist jobs. So they go on and they just basically star the ones that they're interested in. So we could store that and show those. That would be definitely of interest to the user. We could do something like, okay, as a user visits the site, we could track them through and keep the last 20 jobs that they looked at. So if in the morning they're like looking at some jobs and then they go on the train and they're halfway through the classic you're in your tunnel type situation, they could go there and actually look at the offline version and just reread that job that they were interested in and maybe consider the jobs are there. I think that would be very useful just to keep that little tiny history for them. Maybe it'd be 20 jobs, maybe it'd 30, I don't know, whatever, but like a subset of the job that they looked at. And then obviously if they're applying for a job, we could keep that information there because that's really useful, you know, what state the applications are in, when they made the application, all of that type of information. So I mocked this up to show you what I think a small step sort of into offline progressive web app would look like for the Guardian. But then I thought, well, maybe you just think, that's me and I know these particular sites very well. So I went a step further and just took 2 other web experiences that I've been involved in the last few weeks and thought, what might they look like as well? Just purely making up out on my own. So one, I went over to Dusseldorf a little while ago, flew on British Airways. Wouldn't it be great if the British Airways mobile site offlined both the boarding passes and my bookings so that I have the pertinent information, just that stuff. I'm not expecting to be able to search for flights. I know I can't do that when I'm offline, but at least I should have that. I should have that piece of information. And really funny, I did actually do these mock-ups about 3 weeks ago, and then at the Progressive Web Apps conference just this week, an airline from Berlin has actually done exactly this, which is great. So that proves my point. I'm really happy about that because it was just a sort of rough idea. And then equally as well, you know, Amazon, like all of us, I use Amazon for ordering different stuff. These are the books that I've got on order at the moment. You know, Amazon could provide me just basically my current orders that are offline, which ones I've got and when they're going to be delivered. You know, that would be really useful. Again, I don't expect to be able to search Amazon. That'd be stupid. They have hundreds of thousands of products. I'm not going to be able to do that, but they could provide me this. So the end of that point that Andrew made, he actually said this bit, which I think is a good statement as well, which is some of this stuff can be done easily, if not elegantly, and we don't have to like fork the whole thing and build a completely brand new new UI and sort of like and go down that route. We can just enhance what we've already got. So those mock-ups were not me adding new features to the site, so we're just paring back the menu to those features that I think should be offline because they're already part of those sites. Okay, so there's also this debate that's going on at the moment about app shell. And actually, I think this debate about app shell is just another version of what I've just talked about. So if you haven't come across the concept AppShell, has people heard about AppShell? Okay, so at the moment, the Chrome dev group are doing a really good job of trying to explain all the different steps that are involved in trying to offline a website. And to do so, they're trying to come up with phraseologies and terminologies to encapsulate the different steps. And one of these steps is referred to as building the app shell. And what that means is, when you want to offline something, you take all of what we would have called in old terms, the site furniture or the page furniture, the header, the footer, the menu, all of those types of things, and you build a specific cache that saves them. Because actually you can quite easily offline those. You can build a cache that just pulls those pieces of items from within the browser's memory basically and reuses them without them having to go off. And this is just one phase of how you would offline. There's lots of different phases or different recipes, as they refer to as well, of doing offlining. But I think, unfortunately, the app shell thing also implies some other stuff. It implies that you should build a single page app or a singular app, much like the Washington Post one, by the very word app in it. And also, it's not particularly helped by the fact that most of the examples use the material design, which is very related to apps as well. So I think it's just another version of the problem that I just mentioned before. Everybody's really aware of this discussion. Absolutely. It was very nice at the summit at the beginning of the week that some of the comments that were coming out, and what this one particularly from Jake Archibald, is we need to change the perception that progressive web apps must be a single page rendered app. They can be either. You can take and enhance a current site and just use rendered web pages and store them into memory, or you can build a single page app using something like Angular or Ember, but the choice is yours. The technology is not descriptive. You can actually use both methodologies. And we need to be careful that the terminology doesn't force people down one way or another, which is the problem with the app cache thing. So the examples I showed you in my little mock-ups, I would refer to them as more site furniture caches than the app shell. And I know it's just a little bit of tweaking on language, but I think it's a very important tweak on language. So back to The Guardian and 14 months ago when I was looking at this. As I've said, I sort of regard this as a mature site. But there's something else that's also very different about this site to some of the modern messaging sites that we see, I don't like Twitter or any of those types of streaming navigations with notification. And I sort of class these types of sites as using document search. I couldn't really find the phraseology that really encapsulates it well, but if I try and explain what I mean by document search, if you look at the interface here, it's pretty much driven by free text search. So in the far side there, people type in and they type their job title in. Behind the scenes, what we actually do is we store all of our jobs in a big SQL cluster, so a classic relational database system. But to the side of that, we use Elasticsearch, which I think a lot of companies do now, like a proper free text searching system as well. And that's what drives this box here. It's sort of paired the text search to GeoSearch as well. So you can say, I'm looking for JavaScript jobs in Brighton or JavaScript jobs in London, and it finds those things for you. So here we have classic free text search over documents that are stored in this case in Elasticsearch. And then secondary to that is a classic facet navigation system. So facet navigations are best explained by what's on Amazon. When you go down the column on the left-hand side, you click on one item, like I don't know if I want to look at books, and then I want to look at computer books, and slowly you work your way through your navigation and it drops you down. And each time it tells you, what the subsections are for each of them, so you drill down through it. And the facets are generated automatically from the data that's stored. Typically, strangely, we find that some people like this type of search and some people like that. We never got to a point where one's dominated another. And to be honest, they're often found together, and that's why something like Solar, which is another sort of variant of Elasticsearch, they're all based off the same underlying technology, which is a Lucene engine. They also include facets as part of the core of their system. So I was looking at this and saying, mature sites, I'm interested in offlining. I can do the bit that I showed you in my mock-ups, but how could I extend that further? What could I do to move this type of functionality into the offline world? Because I'm really interested in this sort of document type searching, and I want to bring that into my offline experience. So maybe not the first step of like when I enhance a site, but I'd probably do what I showed you, the first step, but then what would the second step would be? And could I produce a piece of technology that would allow me to do that? And that's where this project came in. That's why I started this project, not actually to produce a library for people to use, but for me to experiment with that concept and find out where the limits are. So Manny is a document search tool based in JavaScript. It's actually up online. I have put it up online. It's on the GitHub repository. It has a great big label at the top of it saying unstable API because it is an experiment and I don't want people to think otherwise. But I have fully documented it and so that people can play with it and use it, and you can play with it as well. But I'll show you it in a second. This tweet came out and I think it's absolutely great. Yes, friends should stop friends from building databases. Yes, yeah, absolutely. Databases are complex things. You need a lot of hardcore domain knowledge to really build a proper one and to get it performant. And maybe I shouldn't be trying to build my own database that runs offline. But I think there's another thing that comes with this statement as well, that sometimes it's really great to lift the bonnet and tinker with an engine, because in doing so you find the limits of a technology, and in doing that it gives you ideas about maybe possibilities that you wouldn't have thought about otherwise. I often do this, play with technologies just to find out where the borders are, and this project is definitely that. So before I get into doing the demo, I'll just show you, I'm only going to show you a tiny bit of code because then I'm going to show you how it works. But just so you know how easy it is to set something like this up. For free text search, you need to create an index. There's no real value in indexing everything. There's certain things like Boolean information that wouldn't be good. You're really interested in specific pieces of text, so you need to decide which pieces of text you want to index. And all the options does is say this field, in this case the title field and the text field I'm interested in, I want you to index those. And on the title field, can you give it a boost of 20? A boost basically tells the index that that's more important text. So if you find the term in there, that's more important than if you find it in the main body of the article in this case. Once you've created the options, it's really simple to set up Manny. You basically instantiate an instance of it, giving it the options, and it then provides you with an index. So you can produce multiple indexes if you want to, but in this case we just produce the one. And then once you've got the index, you add your article or your record, your item to it, and it's added as a JSON object with a series of properties. For the demo that I'm about to show you, what I've done is I've gone on to the Async site and taken all of the events that have ever happened at Async, turned them all into JSON objects, and we're actually running in a browser here. So I've loaded up Manny and I've loaded up the JSON so that we can play with it. Just doing this here. Okay, and to do the search, pretty simple as well. Basically, you take the index .search, and then I'm going to search for the text, and the text I'm searching for is promises. So the next few screens are going to be set up like this, and I'll sit down and show you how they work. On this side, on the left-hand side, you've got basically a text area with some JSON in it, which is going to be the search terms that I'm going to type in. And on this side, it's just going to print out whatever the results are coming from our data set, which is all of the events for Async. So at the moment, it's fired up, promises, and these are the 4 events it's found that have the word promises in. If I change that to CSS, you can see it pretty much straight away changes over to CSS. I can do CSS3 if I want to do CSS3, just back again. We can do things like modules, and you can see that it's actually picking up all of the stuff with modules. I think at this time, if I tell you that what I've actually done is use a whole series of underlying libraries to create this. Obviously, creating it from scratch would be a bit of a silly thing to do. I just wanted to see where the technology went. So the underlying library that runs this is a thing called Lunar.js, which you've probably heard of before. Some of you may have heard of before, which is basically a free text search engine. It's based on that same, well, originally it's sort of based on the concept of Solar, which is one of these Lucene engines. So what it does very quickly is it takes a piece of text, it tokenizes it, and by tokenizing, all I mean is it breaks it up into words. So you've got a whole load of words. It then does this thing called stemming, which sounds really heavy duty, but all that is to take things like like started and turn it to start, and anything starts, and that would go to start as well. So basically it compresses it down to the smallest sort of term. This particular one uses the Martin Porter stemmer, if any of you know are interested in that sort of stuff, but that's basically generally the one that's used for English. So it's pretty good, and its results, when it then searches through, what it actually does is provide a ranking. So when the results come back to me, it injects a score into the JSON records. The score's just a number. The bigger the number, the more it matches. And then I just order on the score. So you can see I've got in there. I've also then on top of that added my own paging. So I can say, okay, page me down to just 2 items. And then if I want to start at item 2, and that way I can create pages through the whole thing, literally by just modifying the start number, and the limit is basically the page limit. I set Manny up so that the results come back without paging information if you don't give it a start at or a limit. But as soon as you give it a start at limit, it also injects the paging information, so you can quickly produce a UI for paging if you want. And that's paging. It also has a sort. So as I said, it actually sorts. I don't think there's much practical use. All I'm doing here is actually hidden behind the scene. Defaulted for text is to sort by the score and reverse the order so that it's at the top. So that's basically the free text stuff. So facets. I didn't really use a library for facets. I just built it myself. It's about 80 lines of code. I think I could even compress it more than that. But facets are actually quite powerful. So at the moment, this is the tags. So you can see that we've got 100 odd tags with that. What else can we look at? Okay, so we can do oops, you have to excuse my typing. I think it's venues dot name or venue. There you go. So those so we're nearly at the point where Middle Street's just about to take over from the Skiff as like the venue of choice. You can see history moving on a bit like that. Or we could do more interesting maybe is speakers. That's actually an array. So I built into this a whole sort of JSON pathing thing. So when I'm doing the path there, it's basically just pathing into the JSON and saying, give me the object speaker, that's an array, so give me the first item of it, and then give me the name of the speaker. And there you can see, Dan's done the most talks. That's quite interesting. I'm down there though, at number 3 talks. So. But we can start to add a few extra bits to that. So again, I can put a limit in. So if I just want 4 of them, I can facet limit it. One of the things that's quite interesting when you're dealing with tags is that they can often come in mixed case. So I just put in quickly a case, lower case in system, because I find that quite useful when dealing with it. So we've got those there. But the next bit is you can then combine the facets with the free text search. So if you see down the bottom there, it's got text equals CSS. So what we've got here is a facet structure related to the speakers that have talked about CSS and the counts that they've done. So it's starting to combine together the 2 different things. You have to remember this is all operating in this browser. None of this is going back to the server. So obviously I've got my free text search, and I've got my facets. I'm probably still going to do structured queries. So structured queries are what you classically do with a database. So here, there's lots of ways to query. At the time I was building this, I was doing a lot of MongoDB work. So I've basically used a cut down MongoDB querying system. So it's got like here we've got sponsors equals null. So it's basically saying give me all of the talks that have never been sponsored, and that's the list there. We can do much more complicated operators. So this is like give me everything from a certain date. So I can go, okay, from 15, so you can see that's now cutting down in size. I can do into the month if I want to, 30, and cut it down that way. And then you can start to add them together. So you can also do, here you can see on date, I can do 2 bits into it as well. So I can do from and to as a date range. And down the bottom, I've got something like the sponsors being null, or I could switch that round if I wanted to and do something like, if I can remember the syntax, I think it's going to be not equal, no, yeah, so those are the ones. Is it, which way is it?
Is it EQ?
EQ, not equal, that's it, there we go. I've got them listed on the site. And being dyslexic doesn't help when you're trying to work out which way round letters are. But anyway, yeah, you can see it does structured queries. It's not a full list of what you can get on MongoDB, but it's it's a reasonable list to allow you to do sort of structured queries, which you can also join in. So that's great and good. The next thing I want is geo, and specifically the one that I'm really interested in, because there's lots of ways of searching on geo. You can search within a sort of bounded area, but the one that I really like is the sort of nearby type searches. So I took the GeoLib library, and if you've not used it before, fantastic library, really great, can do stuff like find out what's nearest to you. It does calculations on longitude and latitude, takes into account things like the curvature of the Earth and stuff like that. Really clever. So again, if you're going to do geo stuff, you need to basically create an index, because you need to tell it where the geo information is. So I'm going to swap data sets now. I have like a list of like places that I visit. It's got about 190 in it at the moment. I just sort of keep as part of some other work that I'm doing. So I'm going to use that data set. And within there, it's got a location dot with the longitude and latitude in it. So you just add that to the options and it will create the geo index. I'm also creating a text index at the same time from the same data. So the geo, going again, you can see here, basically the search is kicked off near, you just say nearby, give it the longitude and latitude. That longitude and latitude is for this room, I believe, or somewhere near this room. And if I start to actually delete out the specificity of it, you can see that it drops away. And goes to slightly wider position. You can do an offset. So an offset is basically, if I set that to 0, you can see Middle Street comes up first because that's the nearest, so it's like within 1 metre of where I am, which is about right. And clear left is 14 metres. I don't know why, that's probably because they're a bit further over that way when I took the reading. But literally just the number that goes in offset is basically deletes from the top of the list. And that's really useful for if you're doing apps where you want to get nearest to where I am at the moment and you don't want to include actually where I am. But also you can just keep going if you want to. So for a bit of a laugh, I've added, if you notice, look at the distances, I've added the concept of British distance, which we don't have any single measurement for. So for me, anything that's nearby is measured in meters. So if we just keep knocking it out, after that, it goes to minutes walked. So I basically, part of the geo library in which I've made available is a conversion from meters to miles and kilometers and stuff like that. And all I've done is divide the miles by 22 minutes, and that gives me how far I go. And then obviously if you go out a little bit further, as soon as you get over a mile, I start talking about miles. That's obviously British measurements, which I've managed to include in there. So, but as with the other stuff, this becomes most powerful when you start to add it together. So you can add nearby searches, and then I can do a structured query on the tags to say pubs. So very important for after we've finished. We know where exactly the nearest pubs are. And of course, the Hot Poles is nearest at 52 meters. So there we go. So I think that works quite well. Okay, so that's the end of the demos. Just to sort of explain a little bit, I'm not going to go into mass about the architecture, but just so you know how it works. Basically, there's a document store that holds the JSON. For the time being, I'm actually holding it in memory, just because it was easy to do while I was building it. And you add, update, and delete and remove from the document store. I then added an event emitters. I built this actually as a node and project, and then browsified it. So it's using the node event emitter thing. So every time a document's changed in any way, whether it's added, removed, updated, it fires events. The two indexes on either side, if you create them, listen for those events, and then they take that document and create what they need so that they can do their own searches. For the text one, that's a really complex sort of B-tree type structure which stores how to do the searches. For the geo one, it's really simple. It's just the ID and the locations. Basically, the linkage is a single ID between them. Then when I execute a search, there's a top piece of logic at the top that just looks at the JSON that you passed in. So you saw the JSON as I built it, and works out how to fire each of these at in sequence, in the right types of sequence. They basically do their search and return the IDs. So that then creates a subset of IDs. That's then passed to the next bit that then does its work and either filters or uses those IDs. And that's how I can integrate one type of search with another type of search to provide sort of like a unified output at the end. And that's how it works. So I could, as long as your document store supports events, so if you could do something with IndexedDB or Dexty or some of the other sort of like offline search things like Pouch and stuff, as long as it's got event in, I can swap that central bit out and make this work, which is what I would plan to do if I moved it forward. But for now, it was just done in memory. There's a few other extra bits to it which you really need if you're going to do this type of thing, which is to serialize your data. So basically, you can see there, when I create an index and I add documents to it, there's two extra functions. There's one which is index to JSON, which basically takes the whole thing, so the compressed indexes plus the document store, and builds a JSON file. That's important because building the indexes, especially the text index, it can be quite performant. It takes quite a lot of CPU. So it's good to actually offlay it and persist it if you want to do that. And that's often done with the Lunar.js for static builds. So if you want to use this type of technology, you can use when you build say a blog, and each time you do a post, you build it statically. You can actually create an index and just send the index and load it straight up. And do it that way, and build the index on node and actually deploy it. And again, obviously, I need a parse function to pull it back in again. Once you've got that, then you've got the next stage, because of course, as soon as you can serialize something, you can persist it. So in this case, again, I just did the simplest thing because I just wanted to see how it would work. I took local forage, forced it to use the IndexedDB as a store, mainly because it's bigger than using any of the other browser storage mechanisms. But it actually dumps the whole thing just as a single file in, just literally just dumps it in. I'm just using that because I want the larger storage bit. The persistence library is pretty small. All it does is listen for those events. So as soon as anything changes in the document store, it asks for a new version of the JSON and persists it back into the thing, so it keeps it up to date all of the time. And I don't have to do any other calls. So once you put this piece of code in, it automatically persists to the browser. And at startup, will lift and load from as well. So as I said, it was built on top of other people's shoulders, so I better give them the kudos they deserve. The FreeSex was done on top of Lunar. The query engine I pinched from this NebDB, I'm not quite sure how to pronounce that. Geolib was the nearby search and local forage for doing the persistence. There's still quite a lot missing from this to make it into something that maybe I would use. It depends on what type of project you're doing. But the things you might want to think about are sync. How do you sync between the server and your device or your browser? Obviously things like PouchDB have got sync built into them, and that's like one of the strong bits. There are things I could use, and maybe by using something else to do the data store, I'll get sync. So I could maybe sit this on top of something else like Pouch or one of the other ones. Real-time updates. So yeah, you know the types of stuff that you get with Pusher or with Firebase, those types of, like when you're building streaming type applications, you might want real-time updates. It depends on what the type of application you are, which of these types of ways of passing data in. I've got some examples of web workers. You definitely want to use web workers to offlay this type of work. Manny is fine. I've run it through a web worker. It absolutely works fine that way. There is a methodology for actually baking it into the actual file so people don't have to do it themselves. I haven't done that yet. I could build it onto IndexedDB rather than memory storage. I want to try that out. The interface is really simple at the moment. I think I should move it over to Promises. I think that's a no-brainer. And then the last thing, which is actually more difficult, and I sort of give a bit of sleight of hand, is that I'm not typing the data types at the moment. So you know that bit where I was showing you about the dates and stuff? That was actually a text comparison. But because I'm using ISO dates, it actually works. But you start moving to things like time zones and stuff like that, then you need to actually type your information, which means that when we're creating the index, I need to go through and say, this is the data you're going to get, and these are the types. It's going to be a number, it's going to be a string or a date, so that the comparators will kick in. Actually, I have actually got the comparators already built in the system that works out from, but I just haven't put the schema in place yet to do that sort of data typing. It is just an experiment. There's loads of other stuff out there. Maybe you don't need to reinvent the wheel. You should look at some of this other stuff. Elastic Lunar, which is a variant of the Lunar one that I'm using, uses a different scoring mechanism. So Lunar is more akin to the scoring mechanism that you'll find on Solar, and Elastic, obviously that one's more akin to the Elasticsearch one. That's important if you want to use server-side search and then replicate it there, because you'll get different listings, and that would be like a bit uncanny valley for some people. Index Promises, a great little library by Jake Archibald, which just basically wraps some of the nastiness of IndexedDB up into a promise library. It's only about 3K. It doesn't completely take away the nastiness of IndexedDB. If you really want to take away all of that stuff, much higher level API is Dixie, really good. Again, Promises, and really does abstract you away from all the mess that is IndexedDB. PouchDB, obviously, you've got the sync, fantastic, you could possibly use that. Hoodie, which builds on top of PouchDB and CouchDB, another project you should look at maybe. Pusher and Firebase, basically for the real-time messaging. I think, it depends on your application design. So, wrapping all up, what did I learn? Because it was an experiment, so there must be some learning out of it. That was the whole point of it. I think the first thing from the design side is that it is okay to build asymmetric offline experiences. It's a valid design decision. So what do I mean by that? Well, I mean, it's probably the opposite to saying it's isomorphic. That's a horrible word where it has to be exactly the same on both the server and the client. And I hope I've shown you some nice designs or nice design ideas which are not completely isomorphic. That doesn't mean you one way or another. It's a bit like the whole thing about whether you build in a single page app or you don't. But I think you need to think about it and make a positive decision, not just follow everybody else and follow the crowd. And there are some really good examples of that. I think the other thing to say is that you should probably follow the tenets that have come with a responsive design, which is don't create a completely different experience. Try and pare down the one that you've got and produce something that's very similar or the same to what you've got. It's like a pared down version. I think that's the best way. But occasionally that's not possible. So a good example of when it's not possible is the sort of Android version of Maps, where they can't can't allow you to view the whole of the world when you're offline, because that's just ridiculous. The database they'd have to store on the phone would be huge. But they are allowing you now to capture certain areas that then go offline, and that's provided as like a separate piece of functionality. It's not. So that's quite interesting. I think that was one of the big learnings for me. Okay, this type of document search, and the free text search, the geo, mixing that with structured queries and facets and stuff, you can provide it. I think I've just demonstrated to you can provide it. The caveats are within very tight constraints. It's only certain sizes of data that you can deal with. I mean, you have to be sensible. So I've shown this to a few people, and the first question they ask me is, how big? How big can I do it? And the answer is, it depends. It depends on the size of your indexes. How much text are you indexing? If you're just indexing titles, then you can do quite a lot. But if you want to take the whole body text from blog articles and do all of that, you'll end up with a very big index. So it does depend, and it depends on your design as well. And a lot of it goes to some of the other constraints that we were talking about. It's not actually obvious straight away, but things like the frequency of updates are really important. If you have something that's like a 10 meg database that you've stored, well, that's fine. You can probably deal with that. You could probably upload that over time. But if that database has to refresh every 3 or 4 days, what's going to happen? Someone's data plan as you continually keep pumping up. And when do you get to do that? When do you get to actually update that? When they open up their web page? Are you going to then start downloading straight away a few megabytes of data? So it depends on the profile of what you're trying to achieve. So within those profiles, and you can look at it, you can get away with it. So the best way is maybe by example. One example that I've just used it for, which I found really useful, was just for a little app for me and my friends for the Great Escape. So the Great Escape thing that's on here, it's 450 odd bands, 30 venues, and they play twice each. Perfect. It's too much for you to go through and scroll through. 400 odd bands playing twice, that's ridiculous. And they've all got things like genre tags added to them. So I can go on Tuesday in the afternoon, what bands that are playing electronic music are playing. And better than that, I can go, if I get to one of the venues, which I often did, and they were full, okay, I'm here, what are the nearest venues to me? So I can go to another venue. Perfect. Small data set, too big for you to scroll through, but just perfect for that type of searching. You could probably stretch from hundreds to thousands, but if you get over the 5,000, 10,000 mark, it will really start to melt and the issue will not be actually performance in terms of searching. It will be about you uploading and keeping the data up to date. So I think I've proved that the techniques and approaches work, but I will again emphasize that this is not production code. Don't take it and try and use it as it stands. I'm just there to prove a point. If I'm brutally honest, I've got it sort of 90% of the way there, and I'm not fixing it up to 100% because I know people start using it, and then I'll have to start supporting it. And I already spend a month a year looking after the Happy Swagger stuff and a lot of the Happy modules, and that's quite enough as it is. But maybe I might do it, but I sort of purposely nobbled it, if I'm honest.